PyMol was designed as a platform for creating publication quality figures and animations of 3D structures of macromolecules. In this session, we'll discuss some tips for making high-quality images in PyMol. First, let's grab our model of hemoglobin 2DN2 from the PDB with the fetch command. Using principles introduced in previous videos, I'll quickly make a few changes to the view to make a nice scene that shows the 4 chains of hemoglobin as cartoons of different colors. Now that we have a scene composed, let's store it and turn on the scene buttons. Note that saving the scene is not necessary, but it ensures that we can return to this representation if we change it by mistake. Before generating the image file, a few other options are worth considering. First, we want to set the background color. PyMol gives a few options under the Display menu: white, black, and gray. I recommend using white for most images, especially ones that will be printed. Note that you can set the background to any desired color using the bg_color command. The next option is background opacity. The default is an opaque background that will be of the chosen color. By unchecking the opaque option under Display Background Opaque, PyMol will produce a transparent background using the alpha channel of the PNG image format. This is very useful if you use the image in a composition in other illustration software or in a presentation. Note that the background color does influence how depth is depicted. Distant elements fade into the background color. So you still want to set the desired background color even if you choose a transparent background. The next step is to set PyMol to maximum quality under the Display Quality menu. By default, PyMol uses an intermediate mode to achieve reasonable quality and responsive performance when navigating the structure. For images, we want the highest possible quality. Finally, for best appearance, images should be ray traced before outputting the image file. Ray tracing computationally simulates the interaction between an object, here the molecule, and rays of light. This produces reflections and shadows and gives the molecule an appearance of a real-life 3D object. There are many ray tracing settings that can be changed here under Setting, Rendering menu, although the defaults are often a very good starting point. Note that anti-aliasing is turned on by default, which is important to generate neat, smooth edges. To ray trace your PyMol scene, either click the Ray button in the top right of the external window or type Ray at the command line. Then, to save the image, either use the File Save Images option in the external window or type png space yourfilename.png at the command line. That will save your image at the size of your PyMol viewport or display window. Often, higher resolution images are needed for publication or video. You can ray trace and output images at high resolution by specifying those parameters on the command line. Ray 2000, 1500 will ray trace an image that contains 2000 horizontal pixels and 1500 vertical pixels. Specifying just one dimension can be useful. For example, Ray 5000 will automatically determine the correct vertical dimension to preserve the current aspect ratio of the display. Now you know the basics to obtain an image of high technical quality. The next step is to develop an editorial eye to compose an effective and pleasing image. This takes time and practice, just like photography. But here are a few general tips. First, I like to use light gray tones for structural elements that are shown for context, and a contrasting color for elements that I want to emphasize. For example, here The 4 hemoglobin chains each have their own bright color, and therefore each is competing for attention. Now, by displaying just one colored chain, this particular colored chain is emphasized, although the other chains are still there to provide context. Second, minimize the unnecessary clutter in your representation so that important elements are easy to identify. For example, here I have displayed as sticks all residues surrounding the heme in one hemoglobin chain. This view is quite busy and cluttered. Now in this version, I have made 2 changes. I only display the side chains of heme interacting residues, hiding the stick's representation of the backbone. Also, by coloring the 2 histidines in the heme, I am drawing attention to these particular elements. A third tip is to explore the slab, or depth of field, which you can do using the scroll wheel on a 3-button mouse. Here I have made it shallow, which improves the depth perception around the heme. A fourth and final tip is also illustrated here. I maintain the convention of showing oxygen in red and nitrogen in blue. That also means that I generally avoid using bright red and blue for other purposes in my illustrations. Here I have used gray, green, and yellow. Now it's your turn to try your hand at making some high-quality and pleasing molecular illustrations.